Hello, my name is Joanna Barbaran. I'm a civil engineer, and today in Ingenia we have here John Reilly and Milagros Sotelo. We're going to be interviewing to John Reilly. He is a civil engineer, and would you present yourself, please?
Hello, everybody. Glad to be on this call. My name is John Reilly. I'm a civil engineer with degrees in civil engineering and structures. But my specialty for the last 30-40 years has been management of megaprojects.
Thank you, John.
Hi, my name is Mila. I am also a civil engineer. I am specialized in risk management, and I've worked with John too. I've received his mentorship, and he's one of the main reasons I'm right now working on the risk management.
Great, Mila. Thank you. And thank you, John, for being here, for making a space in your schedule to support this initiative. I really appreciate that. So, John, would you tell us a bit about how did you decide to study this career?
Well, in high school, I was very good at mathematics and physics and sciences. So naturally, when I looked to go to university, I was looking for a technical course, and engineering appealed to me. Things like medicine did not, so I went into the engineering course in civil engineering in the University of Sydney, and turned out I was quite good at that, and I got good marks, and so I graduated from Sydney with honours and a concentration in structural design and pre-stressed concrete.
Great, so you had a technical background.
Yes.
And what can you tell us about your years in college? What would you highlight from your university years?
Well, the highlights have to do not so much with what I was studying, which was very interesting, but the people I was working with. We had a very broad range of people in different disciplines, so in psychology and physiology and medicine and English, as well as the engineering. So that sort of broadened the way I thought about the application of engineering to what I was going to do. And of course, after 4 years in Sydney, I went to the University of California at Berkeley, which is one of the top engineering schools in the world. And there I learned two things. One is advanced structural design, but the other is I was living in International House. International House is a mixture of 50% international students and 50% United States students. So there I brought in friendships with people all over the world. And so then I started to think also about philosophy and other ways to think about how we operate in our world. So I think that was more broadening of my technical background to how does it apply to actual people in the world with different disciplines. So after Berkeley, I went to Canada, and I worked up in Canada for years designing buildings. And then I took a huge trip across Canada and then to Japan and then to Hong Kong and then over to Borneo and back to Australia. Where I started working on an elevated freeway structure. So, I mean, that's just the start of two things. One is technical education, but then is the understanding of a broader application of who we are and what we do as we apply technology, for example, structural engineering.
Exactly. Thank you. And also you mentioned the network that you get to do while you were studying in these places and living in this international house. What would you say about the soft skills that engineers must develop in every situation?
Yeah, there's a link between that time and those skills, which I didn't realize how they were important at that time. But as it's gone on, I've realized that it's not about technology as much as the ability to use that technology in a particular project and how we should do that. So that gets to the communication skills. But I think I need to tell you at this point that my work was technical and management on the Washington Metro system. Then in Boston, on a project that I was the project director for, that had not just technical problems, but political problems. And there was a change in the politics, which was a threat to the project. We had to work with that. So at that point, I'm beginning to understand the technology, structural engineering, and all the technologies that go into a transit system, which include electrical engineering, mechanical, urban design, urban planning, and all of those, and how to pull all those together in a political environment, which is challenged. Now, it's a long story of how we solved that problem, but we did. And the project then went on to be delivered under budget close to schedule. It was named the American Society of Civil Engineers Outstanding Achievement Project of 1987. That even though you're facing a terrible situation, very difficult, if you work and make the right decisions and strategies, it's possible to actually make the project work in spite of all those problems. So that's a life lesson of how to think about what we're doing, particularly appropriate now with the virus, for example, and with some of the terrible politics that are going on in the United States.
Of course. And just for people to know, this award that John is talking about, the Outstanding Civil Engineering Achievement, is an annually given prize that honors a project that shows exceptional civil engineering skills and represents significant contribution to civil engineering progress in society. It celebrates the contribution of many engineers in one project. So that's admirable, John.
Yes, it was great. Nice to have. So we finished that project, and then I decided I was asked by a colleague to help him with a different question that had to do with management of a very large engineering company in the United States that was linked to a very large German construction company. So that got me more into management and opportunities and strategic thinking and planning and marketing, and how to create a new environment for a 1,000-person company in the United States. So we did that, and then, of course, I went on to then consult on other projects, including the Los Metro system, the San Francisco system, up in Toronto in Canada. And so that began to broaden both the understanding of how these projects work in different political environments, different countries, different cultures. The technology stayed pretty much the same, structural and mechanical and those, but the way in which we pull together a team and form that team and align that team to deliver the project is really what I started to consult with. So that's about 30 years ago now, but it's been what I've been doing ever since. Most recently, big projects were the Washington State Department of Transportation, so the Alaska Way Tunnel, which is the largest tunnel boring machine in the world at the time it was implemented, and the Lake Washington Floating Bridge, the longest floating bridge in the world.
Wow.
Then, with a friend, a colleague, David White, I was asked to come down and help in Lima, Peru with an airport expansion project. So I went down and started to work on that project. When I asked David, what do you need in Lima? He said, everything you do. So that the management, structure, team alignment, risk management, contracting and delivery, all those things. That's what I met Mila. He said, John, I'm interested in risk management. Can I help you?
Yes.
Okay, so that's where you two met.
That's where we two met, in the office in Lima, Peru.
Yes, working at the Lima Airport project expansion. I always tell him, and it's not just me being more than grateful for the passing of knowledge. And I wanted to ask you, now that you're talking about, you mentioned the technical side, management, the political learning that you had through the projects that you were in. How do you see now the difference between being, for example, a client, a consultant, or a contractor in a project? How does that also affect?
Yeah, one of the keys is what we call communications and working relationships. So comes from your responsibility. So if I'm a consultant, I'm more advisory to the project manager. If I'm the project manager, I'm in charge and I have to make decisions and I have to rely on others. I've never been an owner, but I work very well with owners because I think it's just essential to understand responsibility. What the owner's responsibility is, what the engineers, the managers, and how it all fits together, which comes back to team alignment. That's that clarifying roles and responsibilities, communications, work, and relationships. So everybody knows what they have to do and how they're going to work on a team.
Yeah,
so Joanna, there's one other end to this in terms of, one of the things is, what am I doing now? Well, actually, I'm pretty well retired now. So I tried to retire after the Washington projects in 2013, and every time I try and retire, somebody asks me to come and work on a project. So year I've worked on some projects, the last one in Lima. So in 1999 to 2001, I was president of the American Underground Construction Association. So that's an honorary position, it's not paid. But I was asked to lead that association for 2 years. And we had some crises we had to work through, but they just awarded me a Lifetime Achievement Award. So the 2020 Lifetime Achievement Award from the association was supposed to be given at our conference, but the conference had to be cancelled because of the COVID.
Yes.
So I have an award, but it's a theoretical award at this point. But that's kind of the end of the career. Where does all this lead? And now it leads to, okay, how do I apply this by keeping in touch with people like you and the industry and maybe advising about some things on an unpaid basis? So that's why I'm helping with some risk and a few other colleagues. And I've got a call this afternoon with a colleague who's an Italian contractor who's going to be working up in Toronto on the transit program up there. So I'm still involved. I'm still curious. I'm still thinking.
Okay, great, John, and great for you to have time for doing this, labor. And getting back to your years in university, what challenges do you had to overcome during these years?
University years, just doing one of my courses. I mean, it was pretty compatible with engineering, so that wasn't a worry. And I always had good grades, so I was passing okay. One thing, though, that was interesting was the challenge of the courses at the University of California, because they were very advanced. And I realized that the way the professor taught was quite different in some cases. And so I began to select the courses for the way the professor taught, and it was compatible with my learning style. And the reason I say that is, in Australia, you have a whole year, and you go through the year, and you have an exam at the end of the year, and that's how you're graded. So you need to understand all of the things along the way, but it's only critical at the end when you have to demonstrate that you understand all those things. The University of California system and the US system is more testing as you go along. So some of the courses I didn't do well because the instructor marked me all along the way, but there are others that marked based on the end result, and in those I did fine. So it's sort of a life lesson of how do you match the way you operate to the environment you have to work in.
Exactly. And how was the presence of female engineers back in your days?
So there was only one woman in our first class in Sydney University, so there was very little contact with women in engineering. But all my contact were with women in other areas, so arts, science, different areas, and that was the way I broadened sort of social dimension to what I was doing. And of course, the University of California, with all of the international students, there were lots of very talented women, not in engineering, so in sciences and chemistry and arts and education and literary science. But I've actually just recently, now that I have some time, made some contact back with those people. And so it's really interesting then to come back after such a long time and find that I can still contact some of those friends who are from all over the world. Japan, Vietnam, Germany, Austria, different places. So I guess what I'm trying to respond to you by saying the technology is important, but that wasn't so much a challenge for me. It was pulling it all together and integrating it with the social environment. It was more of a challenge to learn. And so it turned out that actually that challenge was very useful in applying it for management of complex programs like the metro program. And so it's important then to integrate all of that. And that leads me to another thought. So you have to understand, or I have to understand, what is my role, and therefore how to relate to people. But I don't direct them what to do, and Mila has talked about this. But I try to educate through question and answer and case studies as to how it might be, and then let the people decide what they do, which means I very rarely am in conflict with the people I'm working with. Other people try and direct and manage directly and make you say you have to do this. Well, that basically builds some resentment, not a effective way to educate, to manage, or to communicate.
To relate, yes.
So, Joanna, there's another component that comes in here, and this is the cultural environment in which we are working.
Yeah.
So the Peruvian culture is very different than the Australian, Canadian, United States, or German culture. And so people think about things differently in terms of their culture.
Yes, of course. I think assertive relationships and assertive communication is really important to develop any relationship at work because you're always working with a team. You're never working alone, right?
Right. And this comes right back to this question of men versus women in an environment. So the way a woman thinks about something on a project is quite different than a man. And it's a bit of a skill to be able to understand that.
Yes.
So in my case, the only way I understood that was having a good working relationship with my mother, my sister, and then my wife, and our daughters, now my grandchildren. So I think at the end of my career, I finally worked it out. So up to now, it's been more of an evolution, an adaptation to how do we operate effectively within a technical environment.
And John, would you tell us a bit about how did you start your professional career? I mean, you already told us where did you study and what projects have you been involved in, but how was when you finished the university and you got to enter into the industry?
Well, I finished University of Sydney. I worked designing structures for a period to earn some money, so I could go to California. I go to California, I graduate then, and now I'm looking for a job as a structural engineer, so I sent letters all over the United States and to Canada, and the people up in Canada called me up and said, John, you're exactly the person we want. We want you to come to Canada. So I went up there, 9 buildings in Vancouver, but I decided I need to travel some more, so after 1 year, I left and did a long travel and then back to Australia, and then I designed some more structures in Sydney. It was time to go travel again, and it turned out that the people I worked with in Sydney, that company was the general consultant for the Washington Metro, and they needed some people some engineers, so they asked if I would work on the Metro. So I did. I walked in as a structural engineer. I worked for a year on structures, and then they said, we have to advance our management of these projects. Can you be one of the people? I said, okay. So then all of a sudden, I'm coordinating the management, as it turned out, of 13 of the metro sections in Washington, D.C. So as a young engineer, I'm asked to help with the management of several of the sections, including the downtown tunnels, tunnel across the mall, up to Capitol Hill, the control center building, and I was secretary to the high-level advisory board. So I'm doing a lot of management rather than structural engineering. And I'm also the most senior consultant in underground construction in the United States. So then I began to understand more management of projects rather than the technology, the design and construction technology. So if we go on from there, what happens is I'm known to many people, and then I get some offers to do other things. So I go into a partnership with a structural engineering firm in Washington, D.C. We do some very advanced work on Washington buildings, including a computer analysis of some of the historic buildings in Washington. And then I'm asked to go to Boston to manage a transit project that is an urban design project that I mentioned, we talked about earlier, became the American Banning Civil Engineering Achievement of 1987.
Yeah. You have explained us a little bit about your whole experience, the path that you have followed to finally discover what you were more interested to, like going from technical to managerial to political, and that's quite of a path. And what can you tell us about the impact that all of your work that you have been doing through all these years had in our society?
Basically, civil engineering contributing to projects so these are metro systems in our urban environment. And of course, as president of the American Underground Construction Association and working with the International Tunneling Association. So I was chair of 2 committees for the international group. And now we're talking about urban design and urban life and the fabric of our societies and how that in terms of transit systems, water supply systems, things like that all are essential for a civil community to work.
Exactly. Well, I think all engineers are present in probably every project of development for our society. So I think the importance of engineers is really high.
Yes.
John, I also wanted to ask you, how do you think that also team alignment part of the work that you do has also impacted in not just as a society, but also some individuals?
Okay, so 2 things. The team alignment process started out of partnering in construction, but what we developed was an application of that process to management of projects. So again, it's working together to most efficiently to deliver the project. And so the keys again are roles, clarity of roles, responsibilities, communications, and working relationships, all directed to the goal. What is the goal? What do we have to achieve? How do we best do that? But integrating people and trusting that they can actually develop ways to deliver a design or another application that you as a manager may not have thought of. And so it's basically allowing people to make suggestions or come up with better ways to do things, which that's what deliver these projects efficiently. Now, Mila, you've asked about the alignment, but the other thing, Joanna, that goes to contributions is risk.
Yes.
And so the story about risk is it's always been a word that's out there, but in the mid-90s, when I was working with the international group, this question came up about risk, and I realized it wasn't treated very well within the professional societies. And so we formed a small group in the International Tunneling Group, and a person from UK, Britain, from Sweden, myself, and we started writing papers that dealt with management, but also the essential role of risk in management. And that developed into a different approach to thinking about projects. And there's a long story about how this happened, but essentially I was asked to come to Seattle and help with one of the big projects there, the Alaska Way Viaduct Replacement Program. And when I got there, the question that the Secretary of Transportation asked, he said, we're not very good at estimating the costs of these projects. They always run over budget. We have trouble with the cost estimate. Can you think of a better way to do cost estimates? I said, well, okay. I called a colleague from Boston, and one Saturday morning we sat down and said, okay, what will we do better? And he said, well, as a manager, I don't trust the estimate from the engineers I get. So what I do is I get a separate group, an independent group, to take that estimate apart and to validate it and come back with what they think the cost should be. And I find there's a big difference between those two costs. So then the question is, okay, what do we do with that? And I said, well, if you do that, you have to deal with uncertainty, with risk. Exactly. So we need to pull risk into the process as well. So in one Saturday morning, we created CVEP, the Cost Estimate Validation Process, which combines cost validation and risk management. So now you have a better way to define the probable cost of a complex project, and because you've identified the risk in a formal risk register, now you have a risk set which you can manage. So that was 2002. So that's 18 years ago. The process developed, we applied it with the projects, it gradually was explained to the Federal Highway, the Federal Transit Administration. They have now adopted it. It's spread to other places, to Canada, down to Peru. Mila walks in and says, can I help you? And now she's managing that type of project for the last year or so. Yeah, that's one of the biggest contributions is that process.
Thank you, John. And what would you recommend to someone that's thinking about studying civil engineering or any engineering, in fact?
Oh, engineering is a wonderful profession because you're advancing projects that help society, working with people. And engineers as a group are a very nice group of people to work with. It's hard to explain that simply, but I think they're more reality-based than other professions. So engineers tend to be very loyal, very productive, have good intentions. So it makes for a good working environment. Okay? Now you add in the technologies, new challenges, new opportunities, and then you do the team alignment process that recognizes people as people who they are, and their value to the project, and it begins to not just be more effective and more efficient, but a much more pleasant environment to work in. And having said that, there are always challenges. They tend to be more political than technical. So what I would encourage people is to understand all of these components, and while you may not be skilled in a particular one, to understand, appreciate that there are those other components, and somebody has to be able to deal with those problems. So then you get to the team integration question. How do you pull it together?
Yeah. No, I think that what John is saying is so true, and something that I think that you kind of learn about relationships between people. Relationships are non-linear, so they have a lot of uncertainty to their dynamic. And that same thing applies to as a relationship that you may have with friends during your college years, and the relationships that you'll have in a team project, and how that's going to be a key for a successful project. It's all about the people, right?
Exactly. So would you share with us any statement that you may have that inspires you?
Well, I think that encouraging the young engineers to understand that they will learn many things on a mega project that are applicable to other projects and will help advance their career. So I think the answer is understand the technology, but don't be afraid of the challenges, and to understand that to solve those challenges involves much more than just technical engineering. It involves a lot more components. And those components are necessary to solve the problem, but it's also very satisfying as a person to work with those other elements. But once you start in engineering, that's a pretty narrow focus, but to actually work on your projects and solve the problems, there are a lot more skills that are necessary, and never stop learning. Always be asking questions, be thinking, reading, studying, talking to people. Now you start to talk about things like psychology and communication and philosophy. Why are we doing what we're doing?
Exactly.
Those are part of the education of an engineer. But it's not the curriculum that you're given at the beginning of your university course. Now, some professors will actually explain this. And I had some professors in both Sydney and Berkeley, California, who brought in this other dimension. Mm-hmm. And so while I didn't realize at the time, I now see that that was a very important part of the education of an engineer. So I would encourage people to understand that engineering is actually a lot broader than the narrow technical subjects that you're learning about.
Thank you, John. I totally agree with you. I think engineering is about solving problems and also never stop learning. So thank you very much for saying this and for being here with us, and you too, Mila.
Very good. Thank you for working on this. It's much appreciated.